Up to now, we have only defined sine and cosine and tangent and the rest of the trigonometric functions for angles that are acute, meaning angles between 0 and 90 degrees, or angles in the first quadrant. And the way we defined the sine and cosine and the rest of the trigonometric functions for these type of angles was by using SOHCAHTOA, by means of a right triangle and using SOHCAHTOA. So sine was defined as opposite over hypotenuse, cosine was defined as adjacent over hypotenuse, and so on. So those that we have discussed at length. But now what we need to talk about is how do you define sine and cosine and tangent and the rest of the functions for angles that are not necessarily between 0 and 90. If it is not between 0 and 90, then you cannot just define it in terms of SOHCAHTOA because that only works when you have a right triangle. So how do you do it? Well, in order to do that, you need to make use of the unit circle. So what is the unit circle? The unit circle is just a circle of radius 1 that has center at the origin, 0, 0. So the unit circle is a circle of radius 1 with center at 0, 0. Okay, so suppose we have that unit circle and we take a point on the unit circle, and for convenience, we're going to draw it on the first quadrant. Again, these points could be anything, like any point on the unit circle in any quadrant, just anywhere on the unit circle. It typically is easier to draw things in the first quadrant. So suppose that then I'm going to draw it on the first quadrant for convenience. And so look at what happens. Starting with a point in the first quadrant, if you consider the angle formed by the point, the origin, and the positive x-axis, so the point, the origin, and the positive x-axis, that would be what? We can label that, call it something, we can call it t. So that angle right there can be used to describe these coordinates in terms of the angle. So the x and y, in other words, can be expressed in terms of the angle. So how do you do that? Well, if you draw this perpendicular, the vertical line going from the vertical segment going from the point xy to the positive x-axis, to the x-axis in general, and then use SOHCAHTOA, what do you get? You're going to get that so you're going to get sine of t. You're going to get sine of t equals SOHCA, so opposite, which is y, over the hypotenuse. This is a unit circle, so this is the radius of the circle because that's the center. So that is 1. So you're going to get y over 1. Or in other words, that means that sine of t equals y. Similarly, if you use cosine, what do you get if you apply cosine to this angle? So ga would be adjacent. So this distance right here is x. So you're going to get cosine of t is adjacent, x over hypotenuse, which is 1 again. X over 1 is just x, so you get cosine of t is x. So look what happens. It turns out then that the x coordinate is nothing but the cosine of t, and the y coordinate is the sine of t. And that happens for when the angle is between 0 and 90. And following the same then logic, we're going to say that if the angle is not between 0 and 90, then this still works. In other words, if you have any angle that is not between 0 and 90, all you have to do is consider then, so suppose you have a circle. If you have any angle that is not between 0 and 90, what you're going to do is you're going to consider the coordinates of the point on the unit circle where this angle and the unit circle intersect. Okay, so you're going to draw the angle and you're going to extend it enough so that you intersect the unit circle, and then the coordinates of that point, that's angle T, the coordinates of that point are going to give you precisely the sine and the cosine. The x is going to be the cosine, and the y is going to be the sine. And that's how you define sine and cosine for angles that are not necessarily between 0 and 90. You draw the angle on the plane with the vertex at the origin. Then you're going to draw the terminal side long enough so that it intersects the unit circle. The coordinates of that point, which is the intersection of the terminal side and the unit circle, the coordinates of that point give you the x, give you the cosine and the sine. The x coordinate is the cosine and the y coordinate is the sine. And that's how you define the sine and the cosine for arbitrary angles. This definition works for any angle whatsoever. All right, and then we can define the tangent as sine over cosine. And this definition is actually consistent with the definition that we know from before from SOHCAHTOA, because if you have a right triangle, let's figure that out. So let's say this is T, and this is, let's say this is what? Y, X, and H for the hypotenuse. All right, so if you figure this out, let's see. Sine of T is so opposite over hypotenuse. And then cosine is SOHCAH, adjacent over hypotenuse. What happens if I divide sine by cosine? Sine by cosine, so sine divided by cosine, is going to be, well, y over h over x over h. Now, dividing by something is the same as multiplying by the reciprocal. So dividing by x over h is the same as multiplying by h over x. And now you can see I can cancel the h's and you're going to end up with y over x. But what is y over x? This is the opposite over the adjacent. This is opposite over adjacent. This is opposite over adjacent, which is precisely the tangent. So then that means that tangent is always the same as the sine over cosine for angles between 0 and 90, and then we say that this actually holds for any angle whatsoever. So for an arbitrary angle, we're going to say that tangent is sine over cosine, and that's how you define tangent for arbitrary angles. And then you define secant and cosecant and cotangent the same way as before. The secant is 1 over cosine, the cosecant is 1 over sine, and the cotangent is 1 over tangent. All right, so with that said, let's do our first example. First example says, a certain angle T corresponds to a point on the unit circle at negative square root of 2 over 2, comma, square root of 2 over 2. Find the cosine, the sine, and the tangent of this angle. Okay, so if you draw a picture, you have the angle. Okay, you don't know how big the angle is, does not matter. But you know the coordinates of that point. They're telling you that when you draw the angle, the terminal side intersects the unit circle at the point negative square root of 2 over 2, comma, square root of 2 over 2. That is the point on the unit circle that corresponds to this angle T. So, given that information, what is cosine of T, sine of T, and tangent of T? Well, because this is a unit circle, the coordinates of that point are precisely the cosine and the sine. So in other words, this tells me that the cosine of T is negative square root of 2 over 2, because that's the x coordinate, And the sine of t is the y-coordinate, square root of 2 over 2. Okay, that's the x-coordinate, and that's the y-coordinate. So the answer is that and that. And now, what is the tangent? The tangent of t is just going to be sine over cosine, which is what? Let's divide. Sine is square root of 2 over 2 over the cosine is negative over square root of 2 over 2. Now, note that the top and the bottom are exactly the same. Everything is exactly the same. So they just cancel and you get negative 1. Okay? Or you can just do it like this. Dividing by something is most same thing as multiplying by the reciprocal, and just carry that out and you'll see that everything cancels. You're going to get negative 1. So tangent of t is negative 1. So you see, we don't really need to know what the angle is in order to find the cosine and the sine and the tangent. As long as we know the coordinates of the point in the unit circle that angle corresponds to, then that's all we need. All right, okay. So here's another example. Find the cosine of 90 degrees and the sine of 90 degrees. Okay, we're doing this without a calculator because the point of this example, even though you can put that in the calculator, is to understand how the cosine and the sine are defined in terms of the unit circle. So suppose we don't know anything about what these things are. What is the cosine of 90? Let's draw a picture of the unit circle. And let's draw the angle 90 degrees. Okay, the angle 90 degrees is this angle right here. The point on the unit circle that is the intersection of the terminal side of that angle and the unit circle is this point right here. And remember that the unit circle has radius 1, so that distance right there is 1. So what are the coordinates of that point? The coordinates of that point should be 0, 1. If you said that, then you're right. It is 0, 1. Now, because that's the point of the unit circle corresponding to that angle of 90 degrees, what does that mean? Well, that means that the cosine of 90 degrees is the x-coordinate, which is 0, and the sine of 90 degrees is the y-coordinate of that point, which is 1. And you can double check this in your calculator, and this is right. Okay, so we didn't even need a calculator to do this because if we know what are the coordinates of the intersection of the terminal side with the unit circle, the x and the y coordinates are precisely the cosine and the sine. So a unit calculator is not needed for that. Let's do this other one with a calculator. Try to figure it out. With that explanation, if you have been following along, try to figure out this question. Find the cosine of pi and the sine of pi. Okay. You pause the video and try it. So here's the answer. So we're going to draw the angle pi. Well, pi is the same as 180 degrees. Pi radians is the same as 180 degrees. So that's this flat angle right here. Okay, it's just flat angle, 180 degrees. So now this is the terminal side of that angle, this one right here. And we find the intersection of the terminal side with the unit circle. It is that point right there. And we find the coordinates of that point. So what are the coordinates of that point? The coordinates of that point are -1, 0. And what does that mean? Well, that means that the cosine of the angle is -1 and the sine of the angle is 0. In other words, the cosine of pi radians, or 180 degrees, is -1, and the sine of pi radians, or 180 degrees, is 0. And again, you can double check that with your calculator, but that is correct. And we didn't need a calculator, all we needed was the picture that I just drew. Okay. Now, look at this example. It says, determine the quadrant of angle T if you know this. So this example is about understanding uh, the relationship between the sines of an angle and the trigonometric values. And what does that mean in terms of where the angle is on the plane, on what quadrant? So the first one says, so again, we're gonna figure out where the angle is in what quadrant if we know certain information. What information? We know that the cosine is less than 0 and the sine is positive. So the cosine is negative and the sine is positive. So if we were to draw this angle on the plane and you consider the terminal side and is going to intersect the circle somewhere, so that intersection is going to satisfy this property. So the cosine is related to the x-coordinate, so the x-coordinate is going to be less than 0. The x-coordinate of that point, the x-coordinate of that intersection, and the y-coordinate, which is the sine, is positive. So in other words, the x-coordinate of the point is going to be negative, and the y-coordinate is going to be positive. So now think about it. In what quadrant do you have the x-coordinate to be negative and the y-coordinate to be positive? What quadrant is that? If you said the second quadrant, then you're right. Somewhere here, then, must be the angle. Because if the point is here, then the x-coordinate would be negative, because you're on the left-hand side, that's negative for the x-coordinate, and then you're above this, the x-axis, so the y-coordinate will be positive. So indeed, that means you're here in the second quadrant. So the answer is quadrant 2. Now, how about if the cosine of the angle is positive and the sine of the angle is negative? Well, the cosine of the angle positive means that the x-coordinate is positive, and the sine is negative means that the y-coordinate is negative. And if you draw the unit circle and think of where that point is on the unit circle satisfying these two conditions, so what quadrant is that? Where the x-coordinate is positive and the y-coordinate is negative. If you set the fourth quadrant, then you're right. In this quadrant, the x-coordinate is positive and the y-coordinate is negative. So your angle is in the fourth quadrant. So this is quadrant 4. Okay, and the angle could be measured this way or that way. But we don't really know. Let's just say it is this one, but it could be just this one, okay? We don't really know. unless you have more information. But either way, whether it's measured like this or like that, it is, the terminal side is still on the fourth quadrant. Okay, now let's do another example where we have a little bit of a twist. It's not just sine and cosine, which are x and y. Now we have cosecant and tangent. So suppose that cosecant is less than 0 and the tangent is less than 0. So in what quadrant is your angle now? Well, let's think about this. What does a cosecant less than 0 mean? Cosecant is 1 over, which trigonometric function is that? 1 over what? If you said sine, that is correct. Yes, cosecant is 1 over sine. So cosecant being negative is exactly the same thing as saying that 1 over sine is negative. 1 over sine of t is negative. But if this is a negative number, 1 over something is a negative number, what that really means is that the bottom has to be a negative number. Because there's no way you're going to get a negative from this unless the bottom is negative. That's the only way that could be negative. So that means then that this sign is negative. Or in other words, the y-coordinate is negative. So we have now that the y-coordinate is negative. All right. And now let's use the other piece of information, the tangent. The tangent is negative. Well, what is the tangent? The tangent is sine over cosine. Now, I know that the sine is negative, and I know that the whole fraction, which is tangent of t, the whole fraction is negative, and I know that the top is negative. So if the top is negative and the whole fraction is negative, what does that say about the bottom? Can the bottom be negative as well? If the top is negative? That cannot be, right? Because if the top is negative and the bottom is negative, negative divided by negative would be positive, not negative. So that means the bottom cannot be negative. So actually, the bottom is positive. If the top is negative and the bottom is positive, the division is going to be negative. So that's what we have. And what does that mean? That means x is positive. So if x is negative, if x is positive and y is negative, what quadrant are we in? So if x is positive and y is negative, in what quadrant are we in? Same as this one. Quadrant 4. Here we're in quadrant 4 again. Quadrant 4. 4 and this one was quadrant 2. Okay, yeah, quadrant 4. Now, if you've been understanding everything so far, pause the video and attempt this one and figure it out, and then let's go over it. Okay, assuming that you're back, let's do it. Secant is 1 over cosine. And the fact that they're telling me that 1 over cosine of t is negative, this fraction is negative, means that the bottom has to be negative, because there's no other way that fraction is negative if the bottom is not negative. So we have then that the cosine is negative. What that means is though is that the x-coordinate is x-coordinate is negative. Okay, so now we have that the x-coordinate is negative. So that means we're on quadrants, so far, we're on quadrants 2 or 3. Now, what is the cotangent? The cotangent is the same as the reciprocal of the tangent. But what is the tangent? So the tangent is sine over cosine. What is the reciprocal of this? The reciprocal of this, if you flip this, this is just going to be cosine over sine. All right, so then I know that the cotangent is positive. I know this fraction is positive. But I also know that the cosine is negative. So if this fraction is positive and the top is, if this fraction is positive and the top is negative, that means that the sine, the bottom, has to be negative. If the top, okay, again, if this is, the whole fraction is positive and the top is negative, the only way this whole thing is positive is if the bottom is also negative. So if you divide negative by negative, you get positive. So then that means that the y coordinate is negative. All right? So now, what does that mean? X is negative and y is negative. So if the x is negative and the y is negative, in what quadrant are you in? This is the third quadrant.